Hello and welcome to Minerals, Rocks, and Fossil Facts. I'm your paleontology teacher, Jen, and it's time for some Throwback Thursday. This is Jean-Léopold Nicolas Frédéric Baron Cuvier, better known simply as Georges Cuvier. He was a French naturalist and zoologist who is known for his work in comparative anatomy, specifically in regards to comparing fossils to living organisms. It's kind of crazy to think that up until him, nobody had considered comparing fossils to living organisms. Now, to be fair, there weren't a lot of people searching for fossils at this point. This was still a relatively new thing. But it's still weird to think that there were people out there who were like, we don't need to compare the dead to the living, right? Like, how would you know you found a mammal versus a bird if you didn't compare it to things that are alive? Anyway, little off topic. His work is considered the foundation of vertebrate paleontology. Part of that is because he expanded the Linnaean taxonomy into phyla and included extinct animals in those. And phyla were not a thing until him. So if you look at old Linnaean taxonomy, he had three kingdoms: Animalia, Vegetabile, I don't know how to pronounce that, and Lapidum. So he just had that, and then he had six main classes under that. So quadrupeds, birds, reptiles and amphibians, fish, insects, and then worms and mollusks. He didn't really break anything out. And then Cuvier comes along and he's like, whoa, first off, we need to break some of this out. Some of this stuff is super different and shouldn't be in the same classes. And one of the big things he did was say, hey, we've got animals that have a backbone and animals that don't have a backbone, and maybe these should be separate. And we obviously have all learned about those differences. So he's made a big impact in the way we learn things, even from the very get-go. But it wasn't just basic biology that he was revolutionizing. He also studied strata in the Paris Basin with Alexandre Brongniart, which established the basic principles of biostratigraphy. They concluded that the layers that had been laid down over an extended period during which there clearly had been faunal succession, and that the area had been submerged under seawater at times and at other times under freshwater. This led to the law of faunal succession, which states that fossils appear and disappear in specific sedimentary rock strata. In other words, we can use certain fossils to tell us how old a rock is and what type of fauna we should be able to find in certain rocks. He also named many famous prehistoric animals that we know of today, such as the mastodon, Megatherium, the giant sloth, and Pterodactylus, who is often mistaken as just straight up pterodactyl. He also described Mosasaurus. He didn't name it, but he did describe it scientifically. I will say his biggest fault is that he was a big proponent of catastrophism, which is the idea that the Earth's geologic features were shaped by sudden, violent events. Now, don't get me wrong, some of them are. Volcanic eruptions and earthquakes are definitely catastrophic, sudden, violent events. But not everything that's been deposited was deposited or created by either of those. Most of it is just sediment being dumped by water in calm environments like rivers or lake bottoms or ocean bottoms, things like that. He was very against evolution, which was primarily proposed by Jean-Baptiste de Lamarck and Geoffroy Saint-Hilaire at the time. Remember, this is before Charles Darwin. A deep-rooted source of his opposition to the gradual transformation of species was his goal of creating an accurate taxonomy based on principles of comparative anatomy. And I hate to break it to the biologists who study living animals, but this is exactly why paleontologists don't like Linnaean taxonomy and don't use it. Like, there's some things that we'll use, like we do have like kingdoms and classes and phyla and things like that, but everything kind of bleeds into everything else, and we try to avoid it. Like, if you ever hear us talking, we'll almost never use anything outside of like genera and species, because everything is a clade until, not even until, most of the time we just talk in clades because it's safer to talk about clades. But anyway, I digress. He was the first person to propose mass extinction, though. His primary evidence for his identifications of mammoths and mastodons as separate extinct species was the structure of their jaws and teeth, and because he saw them as the different animals that they were, he assumed that these extinctions were all catastrophic events. Again, because he likes the catastrophic. It never occurred to him that, yes, certain genera would die off, but they would also have evolved into other things. He also had used evidence from Megatherium. He proposed that Megatherium had belonged to a massive extinct sloth, which he compared its skull to modern extant sloth species. So here's a modern sloth, here's a Megatherium. Their skulls look very, very similar. So that's how he was kind of coming up with they're extinct things. He's not wrong. However, many famous naturalists opposed his extinction theory, including Charles Lyell and Charles Darwin, because unlike Cuvier, they didn't believe that extinction was a sudden process. They believed that, like the Earth, animals collectively undergo gradual change as a species. This widely differed from Cuvier's theory, which seemed to propose that animal extinction was catastrophic, as stated before. Now, we know they were both right. Some extinctions are gradual, while others are catastrophic. Just ask the dinosaurs. I mean, they were definitely a catastrophic extinction, whereas others definitely gradually died off. Like passenger pigeons. We sort of took them out gradually, because humans suck sometimes. Cuvier also speculated that there was a time when reptiles, not mammals, were the dominant form of life on Earth, which was basically confirmed about 2 decades after he had died. So he didn't really get to see all that hard work fruition, but we know he was right. Now, there's even more I can go into. This guy did a lot. And I'll definitely have to do a long-form YouTube video on it because, seriously, dude did a lot. But, for now, you can tune in tomorrow to learn about a well-known group of animals that appeared during the Ordovician period. And until then, I will fossilize you later.